All right, let's dive right into this explainer and put ourselves squarely in the boots of a shotcrete inspector. Today, we're bridging the absolutely crucial gap between understanding harsh site safety hazards and mastering the strict ACI visual core quality grading. We're going to look at this purely through the lens of what you actually need to see and evaluate when you're out there in the field.
Here's our roadmap for today. We're going to cover shotcrete safety hazards, confined spaces and PPE, visual core grading, the evaluation pattern, hit a few field scenarios, and wrap up with final inspector takeaways. Section 1. Shotcrete safety hazards.
Look, extreme hazards? They're just built directly into the shotcrete process. It's a real field problem, mainly because, well, gravity never takes a day off, right? When we're talking about overhead shotcrete, fallout can actually occur hours after placement, usually because of cold conditions or maybe an improper admixture dosage. This is exactly why it matters that you restrict the area. Your absolute best practice here: make sure 0 personnel are working beneath fresh plastic overhead shotcrete until it has actually reached its final set.
Moving on to Section 2, Confined Spaces and PPE.
Now, when you take shotcrete inside confined spaces, think tanks, vaults, deep shafts, the hazards escalate incredibly fast. You're suddenly dealing with a toxic mix of dust, cement particles, mist, accelerator exposure, diesel exhaust, and on top of all that, reduced visibility. This dictates a non-negotiable action. Strict ventilation and respiratory controls absolutely must be established by the project safety program before anyone even thinks about stepping foot inside.
And listen up, because this is a massive exam alert. Do not assume there is a one-size-fits-all setup for your gear. There isn't. The exact personal protective equipment you need is determined entirely by the project's unique hazard assessments. Think about it. What works perfectly on an open highway retaining wall is absolutely not going to cut it for a deep underground transit shaft, right? The project dictates the gear, period.
All right, Section 3, Visual Core Grading. So once the site is secure, we need to evaluate the final product using the ACI 506.6T standard. Keep in mind, this visual evaluation requires a representative sample, which usually means a group of at least 3 cores. And here is a crucial point for the modern standard, another major exam alert for you. You only use these 4 specific categories: very good, good, satisfactory, and poor. Completely ignore the old historical grade 1 through 5 systems you might see in older textbooks. They're out. We evaluate strictly based on voids, sand lenses, delamination, and reinforcement encapsulation.
Which brings us to Section 4, the evaluation pattern.
Now, what's really cool here is that instead of trying to blindly memorize a bunch of independent textbook definitions, we can actually turn this evaluation matrix into a super simple, memorable mathematical pattern. If you look closely at this framework, watch how the maximum allowable void percentage gets worse while the required minimum encapsulation drops. Once you see this pattern, I promise you, you won't be able to unsee it.
Let's break it down. For the very good category, I want you to lock this pair of numbers right into your memory: 25 and 90. That 25% is your maximum void area, and the 90% is your minimum bonded encapsulation. Oh, and a quick aside, at this level, small scattered voids, anything up to 1/4 of an inch, can just simply be ignored. Now, stepping down to the good category, the pattern degrades by exactly 5 and 10. So that brings our limits to a 30% max for voids and 80% for minimum encapsulation. See the math? Plus, those small scattered voids you're allowed to ignore, they bump up slightly to 3/8 of an inch.
And finally, satisfactory lands at 35 for voids and 70 for encapsulation. This right here is the floor. Literally anything mathematically worse than 35 and 70 automatically forces the core into the poor category. So 2590, 3080, 3570. It really is a beautiful logical progression, isn't it? All right, let's jump to Section 5, Field Scenarios.
Let's take this out into the real world and test that framework with a couple of rapid-fire scenarios. Picture this. You're looking at a core that just came back from the lab. It crushed its compressive strength test. It is absolutely rock solid. But as the inspector, you notice that the bonded encapsulation around the rebar is noticeably below our 70% minimum threshold. Let's say it's sitting right at 60%. So what's your call? The only correct action here is to classify it as poor. Why? Because high physical compressive strength can never, and I mean never, compensate for failing the visual encapsulation criteria. If that rebar isn't properly bonded, the structural integrity is compromised. End of story.
Okay, scenario 2. Imagine you're inspecting a group of cores pulled from a heavily congested wall section. We're talking rebar everywhere. You spot some scattered, localized imperfections in just one core, but you don't see those same issues repeated across the rest of the sample group. Do you automatically throw the book at it and apply the same strict standards you would to a super simple, lightly reinforced wall?
From the inspector view, no, you definitely don't. Visual evaluation isn't just some blind mathematical equation where context doesn't matter. The licensed design professional actually has to apply professional judgment here to account for that heavy reinforcement complexity and specific project needs. Your job as an inspector is to observe, verify, and accurately report those variations so the design professional has exactly what they need to make an informed final evaluation.
Finally, Section 6, Final Inspector Takeaways.
We've covered some absolutely vital ground today, so let's lock in your key takeaways before you head out to the site. First up, safety hazards are built directly into the pressurized nature of shotcrete work. Always respect the process. Second, drill that 2590, 3080, 3570 grading pattern into your head for the exam. And remember, you can ignore those really small scattered voids between 1/4 and 3/8 of an inch. And your one major field takeaway? An inspector rigorously observes and reports, but the licensed design professional makes the final call on complex core evaluations. So, I'll leave you with this provocative thought before our next lesson on advanced troubleshooting. When you're staring at a core, are you just measuring holes and numbers, or are you actually reading the structural story it's trying to tell you?